So friends, in this video we are going to learn about analysis of single phase AC circuits which consisting resistive load. In a single phase supply we have two terminals. One is a phase terminal and other is a neutral terminal. So when we connect this single phase supply with a resistive load, then we have to understand that what will be the relationship between the voltage and current, what will be the power factor of purely resistive circuits, and how power exactly varies with respect to time in AC circuits, which are the power which are associated. Like we in the previous video we have seen that there are three powers: active power, reactive power, and apparent power. Apparent is this is a sum of active as well as reactive. So here we need to understand that which power are exist while we have a resistive load, while we have inductive load, and at the same time, let's say if we have a capacitive load. So in order to understand, so let's start our discussion. So this is the AC supply, and this AC supply can be given as V equal to Vm sine omega t. So if I just draw it, so let's say this is omega t. Omega t is also known as theta, and this is the instantaneous value of voltage. So if I plot it, so as my omega t varies from 0 to 2 pi, in between we have some pi, so this V will change from 0 to plus Vm, and then it reach to 0, and then again it reach to minus Vm, and again reach to 0 at 2 pi. Again next cycle will start. Okay, now what will be the waveform of current? So we know that we have identified Vm sine omega t. Now we have purely resistive load and current is flowing through this purely resistive circuits. So current can be given as per Ohm's law. So what Ohm's law states that current is proportional to the voltage and it is divided by R. So here if we have DC supply, so it will be the DC value, but in case of AC, which is continuously changing in the instantaneous manner, so current will be V, which is instantaneous value of voltage divided by resistor. So this V varies as per this equation, Vm sine omega t divided by R. It means that let's say if I have some numerical value of resistor, let's say 10 ohm. So as this voltage here, as this voltage changes, so in proportion to that voltage, current will also change. So this formula can be rewritten like Vm upon R into sine omega t. Now Vm is the peak value of the voltage and R is the resistor. Say for example, if I am having 325 volt peak value and if my resistor is having value of 10, so this is nothing but 325 divided by 10 ohm into sine omega t will gives me 32.5 ampere is the peak value, and then sine omega t. Now if I plot it, so it will follow the sinusoidal waveform like this and will be in phase with a voltage, and the peak value of the current, this is the waveform for current, and peak value of current Im will be nothing but 32.5 ampere. So in short, what is the if I write both the equation for voltage and current, so V can be given as Vm sine omega t, and we given numerical value 325 volt into sine omega t. This is the voltage what we have, and for the current I equal to Vm upon R into sine omega t, and we consider Vm as a 325, resistor is a 10 into sin omega t, thus it become 32.5 into sin omega t. So this is my Im. So if we just look at the sin omega t here also and sin omega t, so we don't have any phase angle between two. So the angle between two means phi, which is the angle between voltage and current, is 0 here. So what is the power factor? So power factor of the circuit is nothing but cosine angle of phi. And what is cosine angle of phi? Cos of 0. So power factor of the circuit will be 1. Okay. Alright, now let's understand how exactly the power will look like. So we know that power is nothing but instantaneous value of voltage multiplied with instantaneous value of current. Now what is voltage here? Voltage is nothing but Vm sin omega t. Notice current here, Im sin omega t. Now if I just combine Vm Im, so what I will left with sin square omega t, okay, or 2 sin omega t sin omega t. So let me write in this way, sin omega t into sin omega t. Now if I multiply with 2 and if I divide with 2, so this will gives me this expression Vm Im by 2 into 2 sin omega t sin omega t. Okay. Now we are knowing that if we have, let's say, 2 sin A sin B, so this can be written as cos A minus B minus cos A plus B. So here applying this formula we can write here cos omega t minus omega t minus cos omega t plus omega t cos omega t plus omega t. Here this omega t minus omega t will become 0. So this will gives me cos 0 minus cos 2 omega t. So cos 0 is 1. So this is Vm Im by 2 1 minus cos 2 omega t. So this is the expression of power in single phase circuits. Here in power what we have is, so this power I can relate with two expression, P average plus P oscillating component. So what is P average? So if I just relate this thing, so this is Vm Im by 2 is the average power, and then Vm Im by 2 into cos 2 omega t is the oscillating power in the single phase circuits. So if we understand this with pictorial representation, so our voltage is, let's say, like this AC, this is my voltage, and my current is like this. So power is nothing but instantaneous, like multiplication of instantaneous value of voltage and current. So if I just multiply them, so here as this voltage and current both are positive from here to here, so I will have kind of power will look like this, positive. And similarly here this is also V I and this is V, and if I multiply negative negative it will again become positive. Okay, so this part VMIM is the average part, so this is my average power VMIM by 2, and there is some sort of oscillations with 2 omega frequency, so this oscillations like this. Okay, so due to this the average power looks like this in a single phase AC circuits. Okay, and as we have discussed that, so here the angle between voltage and current is 0. So what will be the cos phi? Cos phi is the power factor. So this power factor cos 0 will be 1. So what is active power? It is VI cos phi, and what is reactive power? Q is Vi sin phi. So here as cos phi is 1, so P is active power is nothing but Va into I. What is reactive power? Sin phi is 0, so this will be 0. So in short, in the purely resistive element, what we have is only active power, and reactive power always will be 0. So the apparent power, which is the phasor sum of active as well as reactive, so active power can be given by Vi and reactive power is 0, so the active power is equal to apparent power.